In an earlier segment, we had a brief discussion about mathematical modeling. We talked about taking information about a couple of variables, it's kind of historical information, a year associated with some amount or quantity, something like that. And we talked about putting that information onto a graph. The graph is called a scatter plot. And we talked about methods for finding a mathematical model or an equation that emulates the pattern of the scatter plot. We want to return to that idea now because it's such an important matter and it will come up from time to time in our study of calculus. So we really have to understand how this works and how the graphing calculator is useful in this process. Let's have a look. A V8 car engine is coupled to a dynamometer, and the horsepower Y is measured at different engine speeds X in thousands of RPM. Now the X row is the engine speeds in thousands. So the 1, 2, 3 and so on. The 1 means 1,000, 2 means 2,000, 3 means 3,000 and so on. Okay, so at 4,000 RPMs the engine is developing 200 horsepower. So the Y row is horsepower for the engine speeds that are listed in the X row. Okay, that's what that's all about. Now, here's what we want to do with this information. First, we want to use the regressive capabilities of a graphing utility to find a cubic model for the data. That just means we're going to generate a regression equation on a graphing calculator, and we're going to use a cubic model for this particular data. We'll see why a cubic model might be effective for the data when we look at the scatter plot for the data in just a moment. Also, we're going to use this graphing utility or the graphing calculator to plot the data, that is, make the scatter plot, and we're also going to graph the model, that is, the regression equation on top of that. And then C, we're going to use the model to approximate the horsepower when the engine is running at 4,500 RPM. You see, we don't have information about 4,500 RPM. We have information about 4,000 RPM and 5,000 RPM, but not 4,500 RPM. So that's how the equation can be useful to us. Well, we're going to go through the steps here, and here's our information, and just for your reference here, and I'm actually going to go through this a couple of times. We're going to go through it here with the animation. I'm going to talk through what we're doing and the step-by-step way of dealing with the information. And then we're going to go through it again on the TI-83, and then we're going to go through it again on the TI-86. So we're going to get a lot of exposure to the situation here all in one fell swoop. First thing we're doing is we're entering the data in the Stat and then Edit menu. So we'll press the Stat button and then Edit, and then we'll enter the information. We'll see what it looks like on the calculator in just a little bit. But recall now, we did something like this in an earlier segment, in an earlier section, when we were talking about a quadratic model. So this should not be totally new information. All right, after entering the data, we want to plot points. And the way we do that is like this. On the TI-83, we begin by pressing Stat Plot. Now, Stat Plot is a second function. It's actually the second function on the Y equals key. And at that point, we're going to turn on a certain plot. If it's not already on, we want to turn it on. And that will allow us to go forward. Now, on the TI-86, this same idea is accomplished by first pressing the button marked Stat and then selecting at the bottom the item for plot, and then turn the item on. So it's a very similar notion. Then we want to set up our window so that we can see the stat plot effectively. We contain all of the information. Now notice that X minimum and Y minimum are both 0. None of the values in the X and Y rows are numbers that are less than 0, you see, and so 0 contains all of these. Now we want to go to the high side. For the X max, we go just a little bit above 6, so we'll use 7. And for the Y max, we'll go to 300. The highest item on the Y column is 245, so 300 should contain it very nicely. So that's the sort of the process or the concept for setting up the window. You just want to contain all of the values left and right and up and down. And then at that point, we go to the graph. All right, as I say, we're going to be looking at this in just a minute, but the way we're going to progress through is that after we press graph, after we look at the scatter plot and we decide that we need a cubic model, we're then going to calculate the regression equation. Now, the regression equation is calculated and found on both calculators by pressing Stat and then selecting Calc. So Stat, Calc, or Calculate will give us the various regression equations, and we select the one that we want. All right, now after we make that selection and we make the calculation, then we'd like to graph the regression equation. It's handled a little bit differently on the two calculators, and again, we're going to go through it a couple of times here. I'm going to go through it, talk through it a little bit here on the animation, and then we're going to talk through the same ideas on the calculator. So if you have one of these calculators, it might be wise for you to take down the steps here and go through them yourself as I go through them on our program here. So on the TI-83, we're going to press Y equals. See, we're just entering the equation, and it's the regression equation that we want to access. And we access it by pressing the button marked VARS, and then in that VARS menu, the item number 5 is statistics. So we'll either press 5 or cursor down to that particular item and press enter. And then we want to cursor over, after we get into statistics, we cursor over to the right twice for the top menu item that's marked EQ for equation. And the very top item is number 1, regression equation. So all we have to do is press enter, and we're accessing or bringing up that regression equation for us to be able to graph in just a moment. Now on the TI-86, it's a little bit different. We access the situation like this. We press from a clear screen now, we press the button marked graph, and that gives us certain menu items at the bottom of the screen. And the one that we want is y of x equals, and then we press Stat. Now notice we're going to the same place that we did before. We're kind of looking for this regression equation, and here's how we find it on the TI-86. We press the button marked Stat, and then we press F5 for VARS. See, it's very similar to the 83, but accessed a little bit differently. So F5 will give us the VARS idea. Then we press More and then More to get different menu items at the bottom. And then we select F2 for the regression equation. And then we press Graph, which is F5. And away we go. We're all set. Well, let's take a look at what all of this looks like from the top. We'll take it from the top on the graphing calculators. Using the TI-83 first, we begin by entering the information. We press Stat, and then we want Edit, which is the top item. And here we are with blank menus. Now, incidentally, if you need to clear the menus, clear the list, that is, on the TI-83, press second and then the plus sign. The second function on the plus sign is memory. And here's what it looks like. Second and then the plus sign would give this. And where it says clear all lists, that's what you would want to access. Just press that twice or enter twice right there, and the list will be cleared for you. At any rate, let's go back to Stat and Edit, and we'll enter the information. In list number 1, we're going to go 1 through 6. So I'm just pressing 1, then cursoring down, and then 2, cursor down, 3, and so on. Okay, and then I'll go over to the other list, and let's see, I want 40. But now understand that this 1 over here means 1,000, so that's 1,000 RPMs will generate 40 horsepower. And then 2,000 RPMs generates 85 horsepower. And away we go. The next item is 140, and then 200, and then 225, and then 245. Now I'll leave this after we've done this. Now we want to look at the scatter plot. And we need to turn the plot on. Now the plot may already be on, but we want to make sure that it is turned on. Now for the TI-83, the stat plot is found as a second function on y equals. So it's just right up here on the calculator. So I'm pressing second and then y equals. and now I want to turn item number 1 on. So I'll select it by pressing enter, and then I will press enter again to turn it on, and now I'm ready to go to the graph. Well, before I graph and look at the scatter plot, I want to make some window settings. So I'll set up the window by pressing window, and now the x minimum, remember, I want to be 0. The x max is 7. The y min we said was 0, and the y max 300. And now I'm ready to graph. Here's the scatter plot. Well, notice that the pattern here that the scatter plot is taking, it's kind of, you know, it's not just a single curve like this. It kind of looks like it's making an upward curve here, and then it's changing and making sort of a downward curve through here, and that's why a cubic model is going to be very effective for this data. Well, let's see. Now it's time to perform the regression equation. To calculate the regression equation, we go into the Stat Calc menu. So I'm pressing the Stat button, and now I want to calculate. So I will cursor to the right for calculate, and I go down here and select the equation that I'm looking for. It's the cubic regression that I'm after, and I'll press enter and then enter again, and the calculation is made. Now notice that the equation, this tells us that the equation is in this form. That is ax cubed plus bx squared plus cx plus d, and this is the value of a through d. And the r squared is a coefficient of determination. It tells us the accuracy with which this equation is emulating the data. Will it go through all of those points? Well, pretty doggone close, because we're very close to 1 here with the r squared. Anyway, it's time now for us to go through and graph the regression equation, and we do that by selecting y equals, and now we want to enter the equation. Well, we could have taken down the a through d values and entered by hand the information right here, or we can let the calculator do it for us by selecting the regression equation, and we select that equation on the TI-83 by pressing VARS. And then we want item number 5, this item, so I'll press enter. And we want to cursor over a couple of times to EQ for equation. It's the regression equation that we want, so we'll just press enter here. And now we have our information about the equation, and we'll press graph and graph the equation. Well, the problem was asking us, the last part of the problem was, you know, we've performed the A and B parts. The last part, the C part, was to use this model to approximate the horsepower when the engine is running at 4,500 RPM. Well, pressing trace. Now I'm jumping onto the scatter plot here. As I cursor to the right, I'm hitting on scatter plot points. If I cursor up or down, I'll jump onto the other graph, and that's what I really want. Now the 3.5 for X means 3,500 RPM, and the 168.59 for Y means 168.59 horsepower for that RPM of 3,500. Well, what we're looking for in the problem is the horsepower that corresponds with 4,500 RPM. So we'll cursor over to the right until we land on 4.5. for the 4,500. Well, I can't quite land on exactly 4.5. I'm kind of straddling 4.5 here. We know from experience that we could zoom in at this point and get a more accurate value, but we're looking at a horsepower here of 213 and here of 216, so it's in the neighborhood of, let's say, 214 or 215 horsepower for an RPM of 4,500. That's the whole point in the problem, though, is to be able to extract information from the data by using this regression equation and its graph. Well, let's look at the whole situation on the TI-86. The TI-86 has a somewhat different feeling to it. I'll just slide it in here, and we'll start over on the problem. I am turning the calculator on, and away we go. Let's see. We want to enter the data, and we do that in the Stat Edit menu. Now, Stat is a second function on the TI-86. It's a second function on the plus sign. So I'm pressing second and then the plus sign to get the Stat menu. and we have menu items at the bottom. We want to edit, so we'll press F2 for edit. And notice that I have already entered the information into the two columns. Now notice the columns are marked X stat, Y stat. No big deal. It's the same idea as the lists were on the TI-83. The next idea is to turn the stat plot on. So we'll press stat and then plot. So we're going back, I'm pressing second plus sign for stat, and then the plot idea. Okay, and we want to turn that first item on. Now, notice at the bottom we have the items that we're selecting. This is the way you make selections on the TI-86. It's by using the function keys. So it's plot number 1 that we want to turn on, and I'm pressing enter here for the on idea. And now notice that the items that are below, we could make some changes here, but the X list is called X stat and the Y list is called Y stat, and we could change these if we need to for other more sophisticated situations, and the mark that we're using is this little mark as we had on the TI-83. Okay, let's take a look at the graph. We first have to set up the window, and to make the window settings we press on this calculator, we press graph, and then for the window it's F2, and let's see. I have it all set up, so that's all ready to go for us, and now we're ready to graph, and graphing is simply F5, and here's the graph. Okay, and once again we would make that, we would look at the scatter plot and decide that a cubic regression is what we're interested in here, and so we go through that process by pressing stat calculate or stat calc. So again, we go to the stat menu, and then we want to perform a calculation, and now the calculation that we want, now it's the items at the bottom that we're looking to calculate here, and so I don't see what I'm looking for on this menu, but notice the right arrow here indicates that there are more items to be accessed, and so we press the button marked more, and we have some other items, and then we could press the button marked more again. You see, for more items, and I'm going to continue to press the more button just to show you the various items that are on here. We're starting over at this point, but we're looking for a cubic regression, and that's a third degree polynomial, and that's the P3 regression that we're looking for. So I'll press F5 for that, and then enter, and it's thinking, and here it is. And now it's showing up a little bit different than the way that it showed up on the TI-83, but the calculation has been made, and we're not clearly seeing the values for A, B, and C. Notice the dot, dot, dot here indicating that we can slide over here on this particular window. But let's just go through and jump into the equation format, because that's really what we would do here. We're not interested in the exact values for A, B, C, and D. We want to graph this cubic regression, this regression equation. So we do that by pressing graph, and then F1 for yx equals, and now we want to enter the regression equation. And we do that by going into the stat menu. Again, that's the second function on plus. We want vars, which is F5. Now we want an item at the bottom of the menu. Now you see, we want an item that's down here, but we have to slide over a little bit to get to it. So we press more, and then more again, and we have the regression equation listed here. And that's the one that we want to select, so we're selecting F2. There's the regression equation, and now we go to the graph. So I'm going to press graph, the graph button, and then F5, and here's our graph coming up. Now, and once again, once the graph shows up, we're able to press trace and then go to particular points on our graph, and so we can do that with trace. And then now notice again that we're on the stat plot or the scatter plot here. When I press the down arrow key, once again I'm on the graph of the regression equation. And as we did before, we can slide right on over to the point where we have 4.5. It landed right on the 4.5 here. There are slightly different numbers of pixels on the TI-86, and that's why the values are not exactly the same as they came up before. The distances left and right are just a little different. So we're able to land exactly on 4.5, and we find that the horsepower for 4,500 RPMs is 214.5.